2012 roads. So we have the contour 5 meter vertical intervals. AB, CDE is the center line of a proposed roadway. O is the center of the circular curves of the proposed roundabout. The following has a road specification. The section of the roadway between A and D is level, at an altitude of 50 mil. I'm just going to write 50 there at D. The section from D to E is falling uniformly at a level of 35 meters at E. There we have 35. Using side slopes of 1 and 1 for cuttings and 1 and 2 for embankments, complete the earthworks necessary to accommodate the roadway on its eastern and southern sides. Note, the earthworks on the western and northern sides of the roadway have already been completed. So, first thing I'm going to work out is so I'm told cuttings is 1 and 1 and fill is 1 and 2. So we have 5 meter vertical intervals, so it's going to be 5 to 5 and it's going to be 5 is to 10. That's the ratio. So the first thing I'm going to have a look at is the actual road itself. So I'm going to work out on A, B, C to D first here. So this here is all level. So if I have a look here, I have contours here 45, 40, 35, 35, 40, 45 and 50. So that there is a point on the road. So the ground here is lower than the actual road. So all this area here is going to be fill. So A to B is going to be fill. Now if we look at B to C, I have 55, 60, 60, 55 and then 50 here. So the roadway here, the earthworks around the road is actually higher than the level of the road, so we're going to have to use some cuttings here. And then from C to D, I have 50 mil here, 45, 40, 35, 40, 45, and then we also have there 50. That there is a point in the road. So this is lower, so we're going to have to use fill for an embankment. So I'm just going to start off there. So we've established that A to B, the level of the earthworks here is going to have to be fill. So the edge of the road is 50 mil or 50 meters altitude. So for every 10 mil I offset from the road, the altitude will drop 5. So the first thing I'm going to do is I'm going to measure out a series of distances here parallel from the road. So I'm going to measure out 10, 20, 30, 40. So this here is an embankment. So this is going to be 45, 40, 35 and 30. So the further I go away from the road, I'm constantly dropping in value. So here I have 45, 40, and 35. So if I look at my contours then, there is my 45 millimeter contour there. Next one here is 40, 35, 35, 40, 45, and then I have 50. So now I can freehand so that area there will be filled. Moving on then, B to C. We see this here, B, the roadway is at 50 meters. So I then have 55, 60, 65, 55, and then I have 50. So I'm going to have to do some cuts here. So cutting is 1:1. So for every 5 mil I offset from the roundabout, the road is increasing in the cuttings are increasing. So I'm going to draw out a line here at any angle, and I'm going to measure 5, 5, so that's 50, 55, 60, 65. And I'm going to use my compass, and it's drawn from the center of the road. So the first one here is 55. This one here is 60. So it's 55 and 60. So I have a look here. Here I have now my 55 millimeter contour. It's a point. Here I have my 60 mil contour. That's a point. 60 mil contour here again. It's a point. And my 55 mil contour again. That's a point. And then my 50 mil contour here, which is there. So now I can put in so that area there is cut. So C to D is also level. Have a look here again. It's 45, 40, 35, 40, 45, and 50s. So it's actually this section of ground here is actually lower than the actual level of the road, so we're going to have to use fill. So I'm going to measure out 10 mil here from the road. That there is going to be 45. And if I can see here, I have a point here and I have a point here. There's no need for me to go out here again for 40 because it will not meet, it won't cross that contour there. So I can draw in my embankment here now. So the next step then, if I read the question, the section from D to E is falling uniformly to a level of 35 meters at E. So it's falling gradually. And the next thing I can look at here as well is I have a 50 mil contour here, then I have 55, I have 60, I have 65, 65, 55. So the road is actually falling this way, but the groundwork all around the road is actually higher than the road, so we're going to have to use cut. So when we're on sloping roads, for thinking of locating the cone is all for cut, it's always located at the lower point. So I'm going to have to locate the cone here at the edge of the road here at E. So my cone is going to be located there. So cut is 1:1. So if I draw a circle here of radius 5, that will give me so somewhere along this line here is going to be a cone drawn here, the center there. So if I draw a circle of radius 5 mil, that will give me a 40 mil altitude, 40 mil. So what I'm actually going to do is I'm going to measure off 5, 10 and 15. So this point here is 40, 45 and 50. So as you can see here, D is at 50, E is at 35. So there's a 15mm gap difference between those two altitudes. And if I look there, I'm going to set up a cone, but my intervals are 5 mil, so that means it'll be my radius of my cone is going to be 3 5s, which is 15. Or alternatively, what I can do is I can measure out a series of 5, 5 and 5, and that will bring me to there to 50. So what I can do now, I have the radius now for my cone, and I'm going to draw in my cone. I join that back to D. So that line there, that line represents 50. So what I'm going to do next then, I'm going to measure off a series of 5 mils along that line there, up as far as 65. That's 55, 60, 65. If I look there, no contour there, there's 70. So I can write that beside there as well. 50, 55, 60, 65. So this is my 55 mil contour. There's my point. Here's my 60 mil contour. And here's my 65 mil. I can also see that this contour here is actually 55. And I can extend on this contour. That's my embankment there. Part B then, the line PQR shows the plan of an underground mine shaft. So this is the plan. The entrance to the mine shaft is located at P and at an altitude of 35 meters. And the shaft slopes down towards the ground at an angle of 10 degrees to the horizontal plane. A section of the mine shaft near Q has collapsed, leaving a group of miners trapped underground. It's proposed to drill a vertical borehole somewhere between points Q and R in order to rescue the miners. Determine and plan the position of the mine shaft and will require the shortest possible vertical borehole. So, somewhere between Q and R. The first thing we're going to have to do is, when we look at this here, all we have is one line going across contours. We have very little information here. So if I take a section view, I will get a section view of the actual terrain. So that's the first thing I need to do. So I'm going to project off at 90 degrees from these points here first of all. So P is the entrance. So I'm going to create an auxiliary, a section view. And what I'm going to create here now is just an X1, Y1. this here is not. This is my xy, x1, y1. So I can see there P is at 35. So I'm going to measure up 35. What I'm going to do then is I'm going to mark off a series of 5s. So what I have here now, I have 35, 40, 45, 50, 55, 60, and 65. So I know that P is at 35 there. So that's P there located. So next step then, what I'm going to do is I'm going to bring up, I'm going to have to transfer heights across here. So 35, there I have my contours there. Next thing I'm going to do then is I'm going to project up along the section here. So this contour here is at 40, that's my point. Next one is at 45. Next one's at 50. $55, 60, 60, 55, 50, 50, 55, and 60. And then P is at 65. So I have the following here as points. What I'm going to do then, I'm going to draw in the profile. So that there here is R. So the entrance to the mine shaft is located at P at an altitude of 35, and the shaft slopes downwards into the ground at an angle of 10 degrees. So the entrance to the shaft is here. And it slopes downwards into the ground at an angle of 10 degrees to the horizontal plane. So this here, my XY line is my horizontal plane. This here is parallel to my horizontal plane. So I'm going to mark off 10 degrees here. that line there in orange, that there is the mine shaft that when the miners are down in the mine, that they come along, that to exit the mine, they're in this mine shaft. And the angle there is 10 degrees. A section of the mine shaft near point Q, so near point Q, a section around here, has collapsed, leaving a group of miners trapped underground. So the mine shaft around here has collapsed, so we cannot access the mine here from P anymore. It's collapsed. It is proposed to drill a vertical borehole somewhere between Q and R in order to rescue the miners. Determine in plan along this line the position of the mine shaft that will require the shortest possible vertical borehole. So by looking at this here, I'm going to have to find a location between Q and R for a borehole that will be the shortest distance to this orange line here. Now, for example, you will not choose R as a location because R is the furthest distance away from the mine shaft. So if you can look here now, the lowest point on that mine is actually here. So that there is the shortest distance from the best location to drill a borehole because it's the shortest distance to the mine shaft. And it's a vertical, it's going to be a vertical borehole. So I'm going to draw in a vertical line here. That line there in blue, that there is the shortest vertical borehole between Q and R. So it says determine in plan the position of the mine shaft that will require the shortest possible vertical borehole. So what we're going to do then is just locate this, transfer this here back onto my borehole. That there in plan is the location of the vertical borehole. That there is 2012 road geometry question complete.